Okay, Assalamualaikum and hi everyone. Okay, so in this video, I'm going to explain to you about normal distribution. Okay, so normal distribution has a bell curve like, looks like graph, okay, which is this one. Okay, so this bell curve is for your normal distribution. Okay, so on your y-axis is the probability density and your x-axis is the z-score. Okay, so from this normal distribution, okay, it can be widespread, okay, depending on what is the value of the standard deviation. Okay, the larger the values of the standard deviation, the more the spreadness of the graph is wider. Okay, so as you can see in the bell curve given here, so we have three different curves. Okay, three different curves and with three different variance values. So variance 9, variance 36 and variance equals to 100. As you all know that variance is actually the square of your standard deviation. Okay, so okay, the bell curve with the pink has the lowest standard deviation. Lowest standard deviation, okay, middle value, and this is the highest. Okay, so the blue curve has the highest standard deviation. So as you can see, the width of the graph is bigger. It's wider for your blue graph. Okay, compared to your green. Okay, so your green is the middle one. So your green is between this one to this one. And compared to the other one, which is your pink. So your pink is between this one and this one. Okay, and as your bell curve is getting wider, okay, from x to in the x-axis is getting wider, it's become shorter. Okay, what does it mean with become shorter? You can see the peak of your bell curve, which is getting lower. Okay, so the higher the standard deviation value, the bigger or the wider is the bell curve, and in the same time the peak is lower, is getting lower. So increase standard deviation, increase width of the bell curve okay, and in the same time it will reduce the peak of the curve. Okay, what does it mean with the peak of the curve? So peak of the curve is actually showing your mode of the curve. So mode is given the highest values where most of the things occupied. Okay, so your probability, okay, for you to calculate probability for your normal distribution, you need to do a standardization process where you need to find out what is your z-score using this formula. So your x minus with mean over your standard deviation, and in the same time, okay, I refer to my right hand side of my screen. So this is the normal distribution table that you need to refer. Okay, as you can see, the z-score that we have is the maximum is 2.9 and is 2.99. Okay, so that means any z-score greater than 3, we assume is equals to 1. Okay, so let's try to find out what is the probability from the given z-score. Okay, so here we don't need to do the standardization process because they already gave you z-score, so we can directly find out what is the probability. Okay, so Pz is greater than 1.11. Okay, let's say this is my bell curve. Okay, so the one at the middle is 0, so 1.11 is somewhere around here. So when it is greater, okay, so when it is greater, that means it's around the shaded area with the red color. Okay, so for your information, okay, so your z-score, okay, from the table, okay, we use z is less than something. Okay, z is less than something to find out what is the probability. So this value is for z less. Okay, so that means it's for this region. Okay, so it's for this region. Okay, but we want to find out what is the red region. Okay, so we need to convert the z greater than 11 to something that we can read, which is 1 minus pz less than 1.11. Okay, pz greater than 1.11. Okay, so how to find out what is the value? Okay, 1 minus z less than 1.11, we can straight away find out the value from our normal distribution table, okay, by referring to your z score. Okay, so here on the left side, in the left column, you need to find out where is 1.1. Okay, so this is 1.1. Okay, maybe my highlighter is too big, I need to reduce the size. Okay, so it's 1.1 is around here. Okay, and it's 1.1, 1.11. So 1.11 here, so that means this is the value of the probability, which is 0.8665. Okay, so just press your calculator to get out the answer, which is 0.1335. So this is your answers for A. Okay, what about for your B? Okay, so B, P, Z less than 1.11 is simply by drawing this bell curve. So this is, let's say this is your 1.111 and it's this blue shaded region. Okay, which is actually equals to your PZ equals to 1.11, and as we already know from the previous exercise, it's 0.8665. Okay, what about when it involves a negative z score? Okay, so let's do C. So PZ less than negative 1.11. Okay, so this is 0, so negative 1.11 is around here. So when it is less, okay, so less means it's smaller than this negative 1.11. Okay, so this one looks like similar to the case where we have z is greater than 1.11. Okay, so P, okay, z less than negative 1.11 is actually equals to PZ greater than 1.11. Why do we need to convert it into a positive z score? Because in your normal distribution table that you are going to refer, we only have positive values of z score. So that's why we need to convert this negative to positive. Okay, so PZ greater than 1.11 is actually equals to 1 minus PZ less than 1.11. So 1 minus 0.8665. So it's equals to 0.1335. So how do I get this? As usual, I refer to my standard normal distribution table, and it's exactly the same value of z score from my previous A and B's question. So that's why I get it 0.8665 without referring to this table. Okay, because it's the same. Okay, what about if we have the second one? Okay, so D, P, Z greater than negative 1.11. Okay, so let's draw a bell curve to show, to have a clearer view. Okay, so this is 0. Okay, so let's say this is negative 1.11. So greater, that means it will occupy, okay, the right hand side region. Okay, the one with the orange. Okay, which actually, okay, this region is just like just now, PZ less than negative 1.11. So indirectly, this one is actually equals to PZ less than 1.11. Okay, so your PZ greater than negative 1.11 is actually equals to PZ less than 1.11. Okay, so your PZ less than 1.11 is 0.866. Okay, what about when it involves these EFG cases where we have intervals? Okay, pardon me. Okay, question G is actually a repeated question to question F. It's just a typo error. So let's do question E first. Okay, so when you have E, okay, so P negative 2, Z negative 1. Okay, so let's draw the bell curve. Okay, so -2 is around here, -1 is around here. Okay, so if let's say I want to reflect it to the positive side, since our Z score it only carries out positive value, so this is 1, this is 2. Okay, it occupies the same area. The area between -2 to -1 is equal. Okay, so area between -2 to -1 is equals to between 1 to 2. So we can use the same concept to find out what is our probability. So P -2 Z -1 is actually equals to P1. Okay, the smaller number 1 when it's positive, Z and is 2. So it's actually equals to P Z less than 2 minus P Z less than 1. Okay. So your Z less than 2, okay, so refer to your standard normal distribution table. Okay, so let's find out what is when Z equals to 2. So this is when your Z score equals to 2.0 and it just 2. So here on the top row is 0, so 0.9772. Okay, so this is 0.9772 minus when your Z is 1. Okay, so 1 it means 1.0 and it's 1.0, so simply 1.00, 0.8413, 0.8413. Okay, we just simply press the calculator to get what is our final answer. Okay, so it's equals to 0. Let's press the calculator. 0.9772 minus 0.8413. So it turns out to be 0.1359. Okay, so let's solve for F when it involves a negative sign. Okay, P -2 less than Z less than 1. Okay, so let's draw our bell curve. Okay, so this is our bell curve. So -2 is about here, 1 is about here. So it's occupy this shaded region. Okay, okay, so it's equals to, okay, when it's -2, okay, P equals to -2. Okay, so it's actually equals to P, okay, Z less than 1 minus P Z greater than -2. So this is based on the given interval. Okay, so PZ less than 2 is just fine. We can read it from the normal distribution table. Okay, what about PZ greater than -2? Okay, so when it's greater than -2, it's actually, okay, is equals to 1 minus P Z, okay, less than 2. Okay, so we have to find out what is PZ1. So PZ1 is 0.8413. Okay, based on this, just now they already find out 0.8413. Okay, so minus 1 minus when Z is less than 2 is this one, 0.9772. Let's press your calculator and find out 0.8413 minus 1 minus 0.9772. Make sure you put a bracket, okay, to separate this one. Okay, so you will get your answers to be 0.8185. Okay, so that is for your questions F. Okay, so what about when we have a modulus function? Okay, so let's solve the one with the modulus. Okay, so we have here P is Z modulus less than 0.56. Okay, when it's modulus, that means it have positive and negative sign. So it's equals to -0.56 Z and then 0.56. Okay, if you want to draw the bell curve, okay, so this is your bell curve. So negative 0.56 is about here, and this is positive 0.56. Okay, so we just use assumption. Okay, so this is the area or the region that we need to find out in order to get what is the probability values. Okay, so we cannot directly find out the answers from this, but we can manipulate it from, okay, this part is, okay, the one in the purple shaded is PZ greater than 0.56. Okay, as we know, okay, the size of the shaded region is exactly the same when it's more than 0.56 and when your PZ is less than negative 0.56, which is equals to PZ greater than 0.56. Okay, and the entire area under this curve is actually equals to 1. Okay, so we can use that information, okay, to find out what is your area of the shaded region or the probability for this modulus. So equals to 1 minus, so we have two region with PZ more than 0.56 to P, okay, Z more than 0.56. Okay, and when it's more than 0.56, as we all know, okay, is actually 1 minus PZ less than 0.56. Okay, so 1 minus 2. Okay, so 1 minus, so you have to locate what is the value of your Z score when your Z score is equal to 0.56. So the probability, okay, so we need to find out. Okay, so 0.5, okay, so here is 0.5, but it's 0.56, so 6 here. So 0.56 is 0, 1, 2, 3, 4, 5, 6. So it's 0.7123. So minus 0.7123. Okay, so then press your calculator to simplify and get your final answer. So 1 minus 2. Make sure put a bracket, okay, to separate this one. So you will get your answers to be 0.4246. Okay, so let's find out what about when your Z score, okay, so in the I questions is greater than 0.56. Okay, let's write this one. Okay, so your I question, P Z modulus is greater than 0.56. Okay, so if we draw the bell curve, okay, so again it's negative 0.56 here and positive 0.56 here. So the region that it covers for this one is this, the one that I shaded with the orange region. Okay, so it's actually equals to 2 times P Z greater than 0.56. Okay, because this one is PZ greater than 0.56. Okay, and this one is for negative Z less than negative 0.56, which has the same area as when Z is greater than 0.56. Okay, so 2, your PZ greater than 0.56 is actually 1 minus PZ less than 0.56. Okay, so 2, 1 minus, so 0.56 is what we already determined just now, which is 0.7123. 0.7123. Okay, so press your calculator to get what is the answers. Okay, so 2, 1 minus 0.7123, and you should get the answers to be 0.57. Okay, I forgot the point. So 0.5754. So that is the probability when your Z score is more than 0.56. Okay. Alright guys, thank you for watching. I'll see you guys in my next video. Bye bye.